Now we know enough about Python that we can start learning about numpy and pandas libraries. NumPy and Pandas are the two of the most common tools used by data scientists. NumPy is popular because it adds support to things like multidimensional arrays and matrices. It also adds a lot of mathematical functions to Python. On the other hand, Pandas allows us to structure and manipulate data the way we want to analyze. What about first we start with NumPy? In order to use all the mathematical and statistical functions inside of NumPy, we need to import NumPy library. So in our Colab or Jupyter, we're going to say import NumPy as NP. So as this, by writing this, that means you import NumPy, but most people they use as NP. So instead of NumPy, we're gonna just write NP. But all the functions inside of NumPy are inside of NP right now. For example, I'm going to create an array, call it num, num equal to np dot array of 1, 2, 3, 4, 5, 6, and 7. So this variable num is an array of NumPy. It means I can apply any statistics or mathematics on it. I'm going to say np dot mean of num. So this gives us the mean of my array, which is 4.0. Or I can say np dot median of my array, same as 4.0. And if you do np.std, gives us the standard deviation. I believe it's 2.0. We did the similar things, mean, median, and standard deviation, a couple weeks ago through a statistical library. A statistical library is if this is that much library, it will be a subset of NumPy library. So if you import a statistic library, you can get mean, median, and standard deviation. But we also can do the same thing with NumPy. In NumPy, we can write something that a statistic library cannot. For example, we can say np dot sign of my array. So the output will be sign of each element of my array, or np dot cosine of num. There are some built-in functions for NumPy that give us extra information about our array. For example, ndim, that gives us a dimension of our array. So if I put num dot ndim, gives us the dimension, and it should give us dimension 1. Or we can say our array dot shape, give us shape of our array, which in this case we have 7 elements, which is 7 comma empty, which is on the 0 index. Now let's have example of 2 dimension. So let me erase this. For 2 dimension, let's call A, gonna call A equal to np dot array of 0, 1, 2, 3, and have, let's call it 10, 11, 12, 13. So this will be the 2 dimension. If we print A, we will get a matrix like we're going to get 0, 1, 2, 3, 10, 11, 12, 13. So now if you say A shape, this gives us the output will be 2, 4. We have 2 row and 4 columns. 1, 2, 3, 4. If we say A dot n dim, the dimension will be, the output will be 2. We also can print number of elements. If you say size, if you say A dot size, it will print, we have 4 here for the 8. The output will be 8. If you, or let's have, change the color. I'm going to say A1. So this will print, so this is the index 0, that's the index 1. This print everything on the index 1 or the row 1. So the output will be 10, 11, 12, 13. We also can change the element. For example, 13 is in the index 0, index 1, and it will be on A 1, 3. This 1 referring to second row or index 1, and 3 goes to index 3. This is index 0, this is index 1, index 2, index 3. So A1, 3, the output will be 13. If you want to change that, same as list, we are able to modify inside of the list or array. Let's change this one to 15. I'm going to say A1, 3 equal to 15. That means 15 will go back for 13. If you print A, the output should be 0, 1, 2, 3, 10, 11, 12, 15. We also can print or slice this one, like A1, so this is going to go to the second row, index 1, comma 0 to 2. Same as lists. We can, so 0, I mean index 0, this is index 1, index 2. So from 0 to 2, and we know we don't include the last one. So the answer is going to be 10 and 11. It will print 10 and 11. All right, I think this is enough for starting NumPy. We will work on NumPy all this semester, and we will learn more about it in each exercise and learn more and more on the mini project and the projects. Now let's talk about pandas. Importing data is one of the most essential and very first steps in any data-related problem. Data exists in many different forms, and not only should we know how to import various types of data, but also how to analyze and manipulate the data to gain useful information. Pandas gives us the capability to read various types of data like CSV, Excel, JSON, HTML, SQL, Pickle, and etc. It allows us to represent our data in a row and column, which makes the data readable and presentable. So now the first thing we're going to do, we're going to import pandas to our Colab or Jupyter. So we're going to write import pandas as name of variable. Usually most people, they use it as PD, pandas. So now the next step is we need to get to our data set. I download a sample COVID-19 dataset from Kaggle. I upload it to skylinedatascience.org website. So we need to go to that page to get the data. So I'm going to create a variable. I will call it df, like a data frame, equal to pd, which is pandas, dot. The file that I downloaded is CSV form. So I'm going to use read underscore CSV parenthesis. So here will be the address of the file. In our case is http colon. So this is the name of the website, and the path is, I think I call it covid.csv. So now this pandas here, this PD, which is referring to this library, it gets this data, the CSV file, and put it inside of df variable. So our df has full of data. If you just type df, so after running this line of code, if you just type df and run it, it will print all the data that df has. It seems like there are around 600,000 row and 23 column, and as you can see, it loads super quickly. Let's view the data now. If you write df.shape, this will print the dimension. It prints around 566,602 by 23 column. So that many rows, and we have 23 columns. If you want to view the data, if you write just df.head parenthesis, if you run this code, it will print the first 5 rows of the data. If you put different number here, if you put 10, it will print the first 10. If you type df.tail, it will print the last 5 data or in your data sets. if we type df.info, this will give some information about each column of the data set. So it's gonna tell us the type of data, what type of data is that, and how many of this data are empty or not empty, or null or not null. And the last one, if you type df.describe, this will print the information like mean, standard deviation, 25%, 50%, or maximum of each column. For example, if there is an age column, it gives us the minimum value of age, maximum value of age. So minimum, maximum, the mean of that, the mean age, and the standard deviation. So it gives us all the information about each column. I think this is enough for Pandas for now, but you will see a lot more built-in function in Pandas.